Okay, all participants can share screen. And I think we're on here. Uh, John, are you on YouTube? Can you see the Fremont Bank thing? Great. All right. Thanks. Ah. All right. Rick, you there?
Hey,
There's Rick.
hello, Rich.
There's John. We got a full
Hey.
house.
Gerald.
All right. Well, good
Yeah,
evening. Good evening,
the
everyone.
nerdy red green, eh?
Nobody's going to know what you're talking about except for one
Except for one
viewer.
person, but we all had to look that one up.
Yeah.
Good evening, everyone, and yes, you've tuned into Crazy Town. It looks like.
Really.
I'm Rich Ozer, and we have Gerald McKeegan and John Curry and Rick Taft, all of whom are in the observatory with nothing to look at because we're completely fogged in. But just in case the cloud should open up, we've got all kinds of cameras and telescopes, but we're probably going to be doing a virtual program tonight, and we have several things to talk about, so we'll have fun anyway. Before we get started, I want to thank our sponsor, Fremont Bank, for supporting this program and others in our community. And I want to remind everyone that the Chabot Space and Science Center, although getting ready to open again to the public in November, is still closed to the public for the duration. And we depend on your donations to keep this program going, as well as all the other virtual programs that Chabot is engaged in. We do have private events happening here at Chabot, so rentals are available for those who are interested, but our public programs won't start until November. So we're all looking forward to that. So anyway, there was something about a blue moon tonight, Gerald. Once in a blue moon.
Yeah.
You got something to say about this?
Yeah. Well, let me share a picture. Let's see if you're gonna let me share a picture here.
Well, I promise you.
Yeah.
I would.
All right. So tonight and early tomorrow, it's the blue moon, and this is the world famous blue moon photo that got us into trouble the last time we had a blue moon.
Wait a second, Gerald. I just got a phone call from the History Channel, and they told you to cease and desist.
So for those of you who don't know, we showed this. There was a blue moon last year on October 31st. We showed this exact same photo at that time. This photo is actually a photograph of the moon taken by yours truly with my telescope, and I tinted it blue to talk about the blue moon back on October 31st.
You mean it's not really blue?
Facebook and their infinite wisdom.
No, it wasn't Facebook.
It wasn't.
Yeah, what happened is it was the History Channel that claimed that the photo was being used on Facebook. So they have a way of fingerprinting photos, and they decided that they own the moon.
Yeah, well, they don't own this photograph. There's a picture I took with my own telescope and adjusted the coloring accordingly. So tonight, actually, it's the official moment of full moon is early tomorrow morning, and it's what we call a blue moon. There are two different definitions for a blue moon. This one is the traditional original definition, which refers to when there are 4 full moons in a season. We're in the summer season right now for those of us in the Northern Hemisphere. It started, I believe, on June 20th, and summer will end officially on September 22nd, if I recall the dates correctly. In this particular case, we have 4 full moons within that time frame, within this summer season. And when you have 4 full moons within one season, the third of the 4th full moons is called a blue moon. So our full moon that we will have later on tonight, for those of us on the West Coast, is the third of 4 full moons in the summer season. So it is considered a blue moon. That happens about once every a little over 2.5 years. I think it's like 2.7 years or something like that. Most of the time within a season is 3 months long, and most of the time you only get 3 full moons within a season. But once in a while you get 4 full moons, and when you do, the third of the fourth is considered the blue moon. Now that's the original definition of the blue moon. In 1946, the magazine Sky and Telescope, which is a very popular magazine among amateur astronomers and a lot of professional astronomers as well, accidentally said that a blue moon was when you had 2 full moons in the same calendar month. So ever since then, whenever we have 2 full moons in the same calendar month, we call the second full moon a blue moon also. So now we have 2 different definitions, but the one tonight is based on the original definition. It's the third of 4 full moons in one season. It will not be blue. It's just a regular old full moon, just like always, except that the timing is a little bit different this time. So this is a highly retouched image of the full moon. So.
It may not be blue, but depending on where you live this week, it may look red. All the smoke.
I was out last night trying to take a picture of the orange moon above my house because of all the smoke we have here in California right now. So,
well, a friend of mine.
So maybe I can.
Sorry, go ahead.
I was saying maybe I can do an orange tinted version too.
Yeah, there you go.
Get another message from History Channel, you know.
Well, a friend of mine had gone out and photographed a very orange moon this week and had posted it on Facebook. And I had seen that photo go by, and I thought that she was just being really late for her eclipse photos. And, and she corrected me tonight. That no, I took that last night. It was from the orange from the fires. And I was like, oh gosh,
Well, you know, speaking of the fires, I was doing a little research on a blue moon today, and apparently you can actually have a blue moon if you have the right particle size, aerosol particles floating around in the atmosphere, most probably from a fire or other event like a volcano
or the Tidy Bowl factory.
But if they are the right size, which is about 1 micron, 1/1,000,000th of an inch, they can scatter light so that what actually appears to us will be blue light, and they'll give the moon a blue tinge. So that's the natural way to get it.
No, that's the unnatural way to get it.
Have you ever seen such a thing happen?
No, I haven't, but I've seen the blue filters, filtered versions. Yeah.
So I guess you can generate your own blue moons if you want.
Yeah.
So I guess the natural event only happens once in a blue moon. All right. Enough of that.
Okay. So wait a minute. While we're still on blue moons, Colleen asks, "What's the fourth moon called?" Well, just a full moon.
It's called the fourth full moon.
Right.
Yeah, I don't believe it's called anything, you know.
Right. Just a full moon.
By the way, the Native Americans, especially up in the Great Lakes region, called the full moon that occurs in mid-August or sometime in this time of the year, they call it the sturgeon moon. So this is also known as the sturgeon moon. This is one tonight.
Sounds pretty fishy to me.
Yeah. The Native Americans gave names to all of the full moons throughout the year. And a lot of those names related to what was going on during the particular season that full moon occurred. So like, I think the one in February is called the snow moon, and I think there's one in April that's called the flower moon, and don't quote me on that, but names like that. So this one is called the sturgeon moon.
I just realized as I was looking at our little Hollywood Squares image here on our Zoom screen that I forgot to introduce Nellie. So what we usually do here is we usually hook up cameras to the huge telescope that's behind Rick and I, and the telescope is Chabot's 36-inch research reflector. And not only is it available for eyeball viewing on Friday and Saturday nights when we're open to the public, but it's also used for near-Earth asteroid research. And Gerald leads up an effort to catalog and calculate orbital elements of near-Earth asteroids. And we've had a couple of episodes of this where he's shown exactly how that's done. But anyway, I don't want to forget to introduce Nellie, and that's Nellie behind me. The other events of the week. We've had a notable opposition, and this week Jupiter was in opposition, and just a couple of weeks ago Saturn was in opposition. And if I can share my screen here, I will show you all what is
Richard,
meant by that.
What's an opposition?
Yeah, what is an opposition?
We're not opposed to anything.
I'm opposed to everything. Hold on. All right, can you guys see this?
Yep.
All right.
Okay.
So in the very center here is the sun, and this only works in a sun-centered solar system, by the way. In the very center is the sun. Here is the Earth, and here is roughly where Jupiter is tonight, and roughly where Saturn is tonight. And I say roughly because it's not exactly tonight's orientation. In fact, this is probably a couple weeks back, right?
Are we looking from the south?
No, I think
If we're looking from the north, you got Jupiter and Saturn in the reverse position. So.
Yeah, I suppose that's true. Well, I just downloaded an example image. It's not really meant to be.
You didn't adjust it for the current time.
Right. Yeah, I didn't adjust it for the current time. This is
not live.
I did not copy and paste to a different part of the circle.
Is that a blue Jupiter or a regular Jupiter?
The general idea here is that a planet is in opposition when it is in line with the sun and the Earth. So in this case, you could see that Saturn would be fully illuminated by the sun from our perspective on the Earth, as would be Jupiter. And so that's what we mean when we say a planet is in opposition. Any other part of its orbit, it's going to be only partially illuminated. It may be up to like 90%, 95% illuminated, but it's partial nonetheless. And when it's on the other side of the sun, it becomes difficult, if not impossible, to see, and it's not considered opposition, even though it's in line with the sun and the Earth. So basically, when the Earth is between the sun and that other planet in roughly a straight line, it's considered to be in opposition. And one of our great treats that we have is looking at the latest image from Damian Peach. And in other, as I like to say, why do I bother? And Damian is a master photographer of Jupiter and Saturn, and he took one last night that is just fantastic of Jupiter.
Oh man!
No, look at that resolution. Yeah.
Now, is that Io?
That is Io. That is Io.
The shadow
here with Io's shadow behind it. Now, of course, if it wasn't in opposition, the shadow would be off to the right or to the left, but it's just behind the planet. And beautiful view of the red spot as well, and also the cloud bands. This is one of his best, I think. I was just staring at this today. I was like, oh my God, it looks like he got into his own private spacecraft and went to Jupiter to photograph this. But this is what you can do when you live or photograph somewhere that has very steady atmosphere, and you have nice video equipment, and you have the patience to go through every single frame you shot and pull out just the really good ones and use those for your final image. And that's
This
the
guy
general
just
method that he uses.
He
Sorry, go
does
ahead.
this over. He does this over and over and over again. And I'm always amazed how he manages to get so much detail out of these images, and often using a telescope just like you and I have in our backyard. You know, I never see Jupiter this well in my backyard.
No,
I mean,
that's amazing.
Damien's latest scope that he's doing this with is a Celestron 11-inch, and it's nothing super fancy. I mean, it's a standard commercial telescope available to anyone. It's not outrageously expensive. He just has his technique down, and that's why he's able to produce these wonderful images. We did have a question though about Nellie. The telescope behind us, Nellie, is a 36-inch diameter mirror, and it is an f8. So I hope that answers your question, Jesse. All right. So much for opposition.
So Alan Roche on Facebook asked about a asteroid flyby that happened earlier today. And yes, Alan, you are correct. There was a fairly large asteroid that made a sort of close flyby earlier today. It was about 1500 Universal Time, which is what, 8 o'clock in the morning here, Pacific Time. And it's pretty big. It's about 1,300 meters in diameter. So a little over 1 kilometer in diameter. It didn't come that close to us, though. It was 8.9 times farther away from the Earth than the Moon is. So you're talking a couple million miles. So, it's dramatic in that it's a larger than typical near-Earth asteroid, but in terms of how close it came to the Earth, it's a nothing burger. So that did happen. There's going to be another one on September 9th, 775 meters, I believe it is. So it's a bit smaller. And it will be about another about another 250,000 miles farther away than the one that just passed by us. So there's big ones out there, and they do sometimes come close to the Earth, but neither one of these poses any threat at all to the Earth. So relax, put your hard hat away, and have another beer.
Since you brought it up, there's been some
Alan brought it up. I didn't bring it up.
Yeah. Oh, you're right. Since Alan brought it up, there's been a couple of other stories floating around that I've only been paying half attention to this week related to near-Earth asteroids, and I'm going to ask you about both of them, and maybe you've been following it more closely. The first is that there's been a lot of speculation about the asteroid Bennu. And Bennu is, if I recall, the asteroid where we had a spacecraft visit. It was the the Japanese spacecraft?
No, Osiris
or is that
Rex.
Ours? It was Osiris Rex.
That's ours.
Got it. Okay.
Right.
So there's been some speculation
which I worked
that
on, by the way.
Oh, did you? I didn't know that.
Yeah.
What part of it did you work on?
Well, if you look at a picture of the spacecraft, it's got a big, huge, high-gain antenna on it, and it's covered with what looks like gold,
foil,
gold tarp, or no, not gold. I'm sorry, a gray tarp. That's actually a type of insulation for controlling the temperature of that antenna, but it has to also be transparent to radio waves because it's an
Sure.
antenna, but it also has to be able to dissipate static electricity because you generate a lot of static electricity when you're out in space because of the solar wind and so forth. So anyway, it's a very specialized material. And I was the program manager for the development of that material. That was actually used on several spacecraft, OSIRIS-REx. I think Mars Reconnaissance Orbiter used some of the material. Mars Insight used it. So it's been around a few times. So that's
really
what I did
cool.
before I retired.
Well, that's
Yeah.
great. I didn't realize you worked on that. The point though that I was making was there had been some news stories about possible future trajectories of Bennu and the probability of it impacting the Earth in 300 years, and then they are talking 600 years. But I know we're going to be asked about it, so I thought I would get it over with now.
Bennu is a near-Earth asteroid, and based on observations before OSIRIS-REx got there, it had a small probability of, there were actually several future dates where it had a small probability of impacting the Earth. However, once OSIRIS-REx went there and orbited around it, they were able to get very precise data about the orbit of Bennu and rule out any impacts for about 300 years. So we're good to go. And there is one, I think it's 2281 or something like that. I forget the exact date. But it's one of these things where there's a tiny probability that it could impact the Earth. But that means that there's a very large probability that it will miss the Earth. So don't read more into it than is there. And that's the case. There's actually a whole list of asteroids that have a non-zero probability of hitting the Earth sometime in the future. But in every case, that probability is less than 1%. So you have nothing to worry about. There was one that got a lot of attention a few years ago called Apophis, that people thought might hit the Earth in the year 2036, I believe it was. But that has since been ruled out as well. So we're as far as the asteroids that we know of are concerned, we don't see anything that's going to be a significant impact in the next 200 years.
Okay, and then the last. Oh, go ahead.
Yeah, the thing you got to remember is we have accounted for about 25,000, 26,000, I forget the exact number, changes almost every day, but we've accounted for about 25,000 near-Earth asteroids. But based on the distribution of those asteroids, the sizes of those asteroids, and the number that we see in each size bucket, we know that there's probably 1 million near-Earth asteroids out there. And so we've only found a small percentage of them. So we have a long way to go yet. Yeah. That'll keep me busy for the next 50 years,
At least. That's right. The last question related to this topic was I had a glance at a news story where NASA is actually planning a mission to attempt to move an asteroid? Or did I imagine this in my sleep?
The DART mission. Yeah, that's called the DART mission, and it's a double asteroid redirect. I forget what the T stands for now. Anyway, it's called DART. That's the name of the mission. It will launch later this year. And sometime next year, it will rendezvous with a binary asteroid, a near-Earth asteroid that's a binary. So it's two asteroids orbiting around each other. One's much bigger than the other one. And what they're going to do is fire a bullet into the smaller of the two asteroids. And they're doing that to test the technology that we would use if we actually detected an asteroid coming toward the Earth with an imminent impact. And if we had enough warning, we could send a spacecraft up and deflect it. And if you do that early enough, years before impact, you only need to deflect it a very small amount, and makes the difference between a hit and a miss. So that's what the purpose of this mission is to go up and test this technology of what's called an impactor, kinetic impactor technology to deflect an asteroid. And that's called DART, and it will launch later this year.
Is Bruce Willis involved?
No, I don't think so. You know, when he found out that they weren't going to be using nuclear explosives, you know, he kind of said,
"Nah.
Where's the fun in that?"
Yeah. Who wants to throw darts?
Yeah. So anyway, see what you caused, Alan.
Yeah.
John, do we have any questions so far?
Not on YouTube. A lot of comments.
All right.
No
we got a couple here on Facebook. Jim, getting back to that photograph, in fact, I'll share it again just so we could. I believe I've still got it up here. Yeah, let me share the screen on the Jupiter photograph again. Jim was noticing these 5 dots down here, and he was wondering if those are still like left over from the impact from the comet from years back. And no, they're not. These are weather features on Jupiter, and they are long-term storms. And it's interesting how they are all lined up like this. I think it's really quite fascinating. The dynamics of Jupiter storms are. Yeah, go ahead. Sorry.
Yeah, if you could zoom way in on those, you know, I'm not suggesting do it, but if we could do it and see it in live, those are actually little swirling patterns, kind of like little cyclones.
Yeah, they're like miniature versions of the red spot in a way, right? Same idea, same type of phenomenon, but not quite as spectacular. And they will be around for a while, and these things come and go, right?
Yes, and as long as you're zoomed in, if you kind of move the image down, you see these kind of elongated dark patches north of the other way.
Oh, I'm sorry. Oh, are you talking about the festoons here?
Yeah, those.
Yeah.
Festoons and barges.
Yeah.
So,
here's a barge and there's a festoon.
Yeah, and these are just names we give to features that we see, recurring features that we see on Jupiter. This goes on all the time. It's a very dynamic place. The reason you see these bands is because Jupiter is rotating very rapidly. I want you to think about this. Jupiter is 11.2 times the diameter of the Earth. So it's huge, 88,000 miles across. And it rotates once every 9 hours and roughly 50 minutes. So it's 11 times bigger than the Earth, and its day is less than half as long as the Earth. So it's spinning very rapidly. And if you can imagine, if it spins that fast and it's that big, the velocity at the equator is extremely high. And so what happens is you get high and low pressure areas in Jupiter's atmosphere, just like you get on Earth. But on Earth, we get these little swirly patterns, you know, highs and lows that you see.
And an occasional hurricane, right? Yeah.
And the occasional hurricane, right? But on Mars, the highs and lows get wrapped all the way around the planet. Or Jupiter, I'm sorry, Jupiter, the highs and lows get wrapped all the way around the planet. So as a general rule, the dark bands are what we call belts. The dark belts are low pressure areas, and the light areas we call zones are high pressure areas. That's a kind of a general rule, but there's a lot more to it than that. So.
Wow. Hey, we got another question since you're mentioning those features. What's up with the red eye? I assume he means the giant red spot getting smaller.
Yeah, here we go.
That's true.
This is the feature we're talking about here. Yeah.
Right. Yeah, over over the course of years and years of observing the red spot, we've noticed that it has gotten smaller and it has faded some. So it's not as red today as it was, say, 20 or 30 years ago. We think the red spot has been around for at least 300 years, and probably more than that. It's just a great big cyclone on Jupiter. We're not exactly sure what has caused it, but it has stayed there for a long time. Now, one of the things that to understand is it does not stay in the same position. So if you were to put a grid on Jupiter, which is kind of hard to do since it's a gas giant, it doesn't have a solid surface. But using the interior magnetic field, we can kind of create some reference points on Jupiter. And if you had a grid relative to that, you would find that the red spot actually wanders along, shifts about, I think I read somewhere it's like 15 degrees a year or something like that. It's quite a bit of drift. So if you are a user of software, planetarium software like Stellarium or something like that, if you hunt around in the settings, there's a place where you actually can set the current longitude of the red spot. So when you look on your software to see whether the red spot is up tonight, it will actually be where the software shows you. So that's kind of an interesting thing, about the red spot.
Thanks for that.
Cool.
Yeah.
Jesse asked, what are the seeing conditions where we are tonight? Well, the seeing is 0.
How about fog?
Yeah. The seeing is 0, which is why you're having to listen to us talk rather than looking at live images from our cameras. But it typically, in the Oakland Hills, the seeing, I would say, is kind of a medium moderate. We don't have great seeing here. We don't have truly awful seeing here on average. I'd say we're somewhere in the middle. It's the best we can do. And there are other places, like the top of Mauna Kea that have excellent seeing. And there are other places in the middle of tall mountain ranges which have far worse, so we don't complain about it too much. In fact, a couple weeks ago when we were here, Gerald and I were looking at Jupiter, and Gerald was looking through Leia, our 8-inch refractor scope, and the visual experience looking at Jupiter was on par with one of Damien Peach's photographs. It was so crystal clear and so crisp and so much detail that it was a perfect seeing night. So we do get those here, and it's always spectacular when we do.
Okay, another question here. Why can't you send rover to Jupiter to study the cyclones? Well, it would have to be more of a drone than a rover if you could.
The Juno mission.
And we do have a spacecraft. Yeah, we have a Juno is orbiting Jupiter right now. And so we are getting close-up images of it.
Not from the surface, because there isn't really an exact surface.
Yeah, you can't put a rover on the surface because there's nothing for it to roll around on. But we do have a spacecraft. We've had a couple of spacecraft orbiting Jupiter over the years. There was Galileo back in the 1990s. Cassini flew by it, and Juno is orbiting around it. Juno is another spacecraft
Juno
that I worked on.
Deeply studying these storms.
Yeah.
Juno is, that's its mission, is to figure the fluid dynamics of Jupiter's atmosphere out.
Yeah, there was another question about the velocity of the winds.
Yeah.
And the velocity of the winds at the red spot and at the equator in general are well over 1,000 miles an hour. So it's windy there.
Well, here's a good. Tim mentioned this. He said the highest speeds can reach 900 miles, close enough, 900 miles per hour. Relative to exactly what, I am not so sure. So that's actually a pretty darn good question. Relative to what? 900 miles
An
an hour.
imaginary spot, right?
An imaginary stationary spot. Yeah. So that feeds into another question we got, and I think it was from Erica? I'm not sure who it was from, but I read it as I scrolled by. Is it the case that storms on Jupiter simply do not dissipate? And they do dissipate, but it takes much, much, much longer. It's not like they hit a landmass, which dissipates the energy. It's like when hurricanes hit land, they don't go traveling across North America and come out the other side. They hit land, and that causes the storm to dissipate because they no longer have the warm water underneath. There's a lot of reasons why it dissipates. With Jupiter, everything just kind of keeps on going because it's just atmosphere, right? But eventually, because of friction from hitting different pressure zones, changes in chemistry, moving off of course, Gerald mentioned that it might move 15, 20 degrees. What happens to a smaller storm if it moves 15, 20 degrees? Well, maybe the energetics change enough for it to completely dissipate. So that's why it's always, always changing. All right.
Yep. Jupiter's a fun place.
Yeah. Yeah, it's a fun place to look at it from a distance. Yeah, you wouldn't want to live there. All right, well, we got a couple of other things. If you guys don't have any other questions at this time, I want to share my screen.
One question while you're getting ready with that.
Yeah.
Where is it now? Somebody wanted to know what our Sunset Science event is all about. You have a good description of that, Gerald?
Sunset Science.
Is that next week?
That's on the 27th. Yes, next Friday. Sunset Science is a kind of a science-themed observing night. So we used to do something called members-only viewing nights, where Chabot members had their own dedicated telescope viewing nights. We're not quite back to doing that yet, but what we've decided to do is once a month do these Sunset Science Nights. And so there's going to be lots of different science projects. We have a group of teenagers here who are much into science called the Galaxy Explorers. They're going to be doing some demonstrations. I'm going to be giving a talk about asteroids, and we are going to have the telescopes open, assuming it's not foggy. We'll have the telescope open for viewing that night. So it's a fun thing, and this is not limited just to Chabot members. If you're interested in coming and you're not a Chabot member, it is a ticketed event, but you can sign up if you go to our website, which is chabotspace.org, and look on the events page. You'll see things about it. You can buy a ticket online and come up and join us. We do have to limit the number of people up here, obviously, because of COVID, but I think we still have some space, so check it out. And maybe I'll see you, and all of us will see you next Friday night. Richard, you're bringing your telescope up, right? Your 11-inch.
And excuse me. Yes, I am. I'm either going to bring the 8-inch or the 11-inch. I'm not sure which. I'll bring something. I promise. All right, so here's something else from the past week that I thought was really interesting. So those of you who have been following us probably remember a couple of weeks ago we showed you this image of the Ring Nebula. This is what we were doing live from Nellie, and this was just taken with our DSLR and several 30-second images all stacked on top of one another to produce this image. But another very well-known astrophotographer named Robert Gendler, he produced an image of the Ring Nebula that looks like this.
Oh, wow. My gosh, yes.
And this is very interesting. He did not take the images. He combined images from the Hubble Space Telescope, the Large Binocular Telescope in Arizona, and the Subaru telescope in Hawaii in order to combine data from all three and show a little bit more about the Ring Nebula than we can normally see even through our own large telescope here in Oakland. So the photo I showed you before is just this center area, which is, you know, a couple few thousand light years across. But if you take very long exposures and especially take exposures in different parts of the spectrum and have instruments that are sensitive to different parts of the spectrum, you realize that the Ring Nebula is a much, much larger object than just the part that we see through our amateur telescopes or our typical terrestrial telescopes. But given enough time and enough patience, you tease out all of this additional data, and you could see that it's a whole series of rings that define the nebula. And every time the white dwarf star that's in the center of this nebula expands and contracts, it spews out another ring of gas. And you can go back in time and see the hydrogen gas that's been spewed out, you know, originally, and then more recently and more recently and more recently as you approach the center. And Gerald, you were going to mention or correct me on something. Go ahead.
Yeah. Most of this gas was expelled when the star was a red giant, not when it's a white dwarf. When it's a red giant, it's not just a nice stable thing that's gradually doing this. It's pulsing. All right.
And well, it's one of those things. It's one of those things where I say what I mean, not what I say.
Yeah.
Right.
Also, you said thousands of light years across. Is that really right?
Well, the
light years.
The right center ring part, the part that we normally see, that's about 1 light year across.
Yeah, 1 light year, not thousands.
Yeah. It's about.
Sure I'm sorry. Yes, it's 2,000 light years away, and it's
2,300 light years.
It's 1 to 3 light years across in this central ring, and then it's about 6 light years across. Sorry about that.
And there's actually more. If you want to, widen your field of view and take even longer exposures, there's actually even more hydrogen gas extending out farther than what you see here. It's real when you do a really wide field, long exposure. It's just amazing how much stuff is out there. And all that red stuff, that is hydrogen gas. Hydrogen gas glows in that kind of deep red color when it's ionized by ultraviolet radiation. The white dwarf at the center is emitting ultraviolet radiation. And so it ionizes that hydrogen gas. The intensity of that red light from the hydrogen gas is not very high compared to the intensity of the blue-green color that comes from the doubly ionized oxygen, which is what you see closer to the center there. The oxygen is not the dominant gas. It's just the gas that dominates the brightness of the colors. And it's just the way the physics works on that. So it's mostly hydrogen everywhere, but there is a lot of oxygen that glows in that reddish or bluish green color. And then the red is all hydrogen.
Bob had pointed out that the white dwarf star, the remnant of the red giant that produced all of this gas, is pretty faint in this image, and there's a reason for that. Yeah. This is a narrow band image, meaning it is looking at very specific spectra of light in order to bring out these gas clouds, and as a result, typical starlight tends to be filtered out. And if this was a standard visual spectrum image, you wouldn't be seeing all of these circular features around the nebula, and the stars would be much brighter all around. So anyway, that's kind of an artifact of shooting in narrowband. All right.
Cool.
By the way, if you want to see photos like that on a more regular basis, there is a website called the Astrophoto of the Day, APOD. And photos like that have a tendency to make it to APOD. And there's every day there's a different photograph, either taken by a talented astrophotographer here on Earth or a talented robot in orbit around the Earth or the Sun, and there's always something good to see there. So it's called the APOD website.
Yeah, apod.nasa.gov. That's the URL. So APOD, apod.nasa.gov. Yeah.
And Tim Thompson just posted it on Facebook, so take a look on the comments section and go ahead and bookmark it. If you have nothing to do, that's a great place to go. All right. Any other questions about that?
So Richard, you and I, actually, I think all four of us, so we're listening earlier to a lecture by a gentleman who was the manager of the Curiosity rover program at JPL. And I thought it would be nice to share something that just came out within the last couple of days. It's a short video that shows a panoramic view of the Mars terrain all around where the Curiosity rover is right now. You know, the rover that's getting all the attention these days is Perseverance. It's the newest one that landed back in February, and it's the one with the helicopter on it and all that. But the Curiosity rover has been on Mars since 2012, and it's still working its way up a mountain, if you will, inside a crater called Gale Crater, and the mountain is called Mount Sharp. And this video, which was posted on YouTube, if I can share it, I will kind of run the video. It does have a narration, so if you'll bear with me. Gotta make sure I
click that box.
Click all those boxes. Click all those boxes.
You gotta click the magic box, or else you don't hear the video.
I'm not sure if I'm there or not. No.
Yeah, we'll find out.
Of that.
Yeah, you gotta double click on it, pause it, then share that window.
Okay, here's my problem right there. Okay, one more time. There it is. Okay, so I want to go ahead and start this.
The terrain around the Curiosity rover is beginning to look very different. The rover has driven over 16 miles since landing in Gale Crater in 2012. This view is from 1,500 feet above our landing site. We're climbing the side of Mount Sharp, a very tall mountain in the center of the crater. All of this dark material is Martian sand that's made up of broken bits of volcanic rock. Can you see the ripples that were shaped by the wind? We had to drive around this massive sand sheet as we climbed Mount Sharp. Look how clear the air is. That's because it's winter, when there's less dust in the atmosphere. You can see all the way to the rim of Gale Crater, which is about 20 miles away. We spent the last several years investigating clay-rich rocks that formed in lakes. But now we're entering a region where rocks are filled with salty minerals called sulfates. These minerals form in drier conditions, so we think this area might show us how the ancient Martian climate was changing. We're starting to see lots of very cool, knobbly textured rocks like these. We think these veins and nodules were created by groundwater. Here we recently drilled our 30-second sample of the mission. By studying the chemicals and minerals in this rock, we can learn how the ancient environment was changing as we go from the clay region into the sulfate region. And these hills are different from anything we've seen on the lower mountain. They're rounded, unlike the ridges and mesas we've seen before. Now let's look ahead to where we're going. We'll soon be entering a narrow valley that should make for some amazing images. On the left is Rafael Navarro Mountain, named after one of the mission's scientists who passed away in January of 2021. This nearby hill is huge. It's about the size of a 4-story building. This changing terrain is more than just fun to look at. It can teach us how Mars lost its water over time. How long did conditions that were favorable to life last? We're looking forward to finding out.
Okay, well, I thought that was kind of interesting, so I thought we'd share it,
Well, that was a really good talk tonight too. And for those who want to learn more about Curiosity and Gale Crater, visit the East Bay Astronomical Society's website. Give it about a few days, maybe as much as a week, for the talk to be posted on our videos page. We have a YouTube channel, and every month we have a speaker, and if they are willing, their talk gets posted to YouTube, and we can share it with the general public that way. So anyway, it was a great talk, and I certainly learned a lot. I had a number of misconceptions about the spacecraft that got corrected, and not the least of which was this spacecraft has a plutonium battery. I had no idea. I thought it was a solar instrument, and it's not. And that was my biggest surprise during the talk.
Yeah. Actually, both Curiosity and Perseverance use RTGs, radioisotope thermal generators, which use little plutonium pellets to generate heat, which then in turn generates electricity. And that way they don't have to worry about, dust getting on their solar cells and things.
Yep, which is a problem for some of the other spacecraft.
Right.
All right. I had only one other thing. I suppose we have enough time.
Before we move on, we do have a question from Renato. Referring back to the images of Mars, are those images edited, prior to showing on the video? Are they colorized, or are we seeing natural colors?
Those are natural color images.
Those are natural colors. Yep.
Yep.
Mars has a very unique coloration to it. You could kind of tell a Martian image right away when you look at it.
Yeah.
The other thing that was kind of interesting about that, the rover was sitting at about 1,500 feet elevation. We are also sitting at 1,500 feet elevation. I'm just saying.
It didn't take me 9 years to get here, though. All right, I do have and hopefully it never will. The other photograph I stumbled upon this week was really interesting. We've talked about a phenomenon called gravitational lensing in the past.
Oh, yes.
And I wanted to show this image. So gravitational lensing is a phenomenon that was predicted by Albert Einstein. And he basically said that, if you've got a massive enough object in the foreground, then light from a background object will bend around that foreground object as if the foreground object was a lens. And that was implying that gravity can function as a lens. Mm-hmm. And what you're seeing in this photograph here is a pair of galaxies. You can see the two bright cores here. And those are the foreground object, right? These are the foreground galaxies. And at some distance behind these galaxies is a quasar. And a quasar is a very distant, very energetic object. There's a lot of mystery about them still, but they're extremely bright, extremely old, and extremely distant. And what you're looking at here is a single quasar showing up to our eye 4 times because the light is being bent and brought to a focus in 4 different places around this pair of galaxies. And I thought this was just a fascinating image. This is part of a larger study to determine the greater precision in the Hubble constant, but they have several of these gravitational lensing images as part of this study, and this one was exceptional. So I wanted to share that tonight.
All right. Hey, speaking of sharing, if I can share one more time. We were talking about the location of Curiosity on Mars, and I've got an image here to show you, just to give you an idea of where it is. This is an image of Gale Crater, and this little oval that you see here, that was the target area for the landing. So it ended up landing right here. This whole inside part right here, this is actually at a lower elevation than the surrounding terrain, and it's at a lower elevation than the central peak of the crater, which is Mount Sharp. So the rover landed there. It worked its way this way for a while, and then it's kind of working its way up the hill here like this. It won't be able to get all the way to the top of Mount Sharp. It gets steeper and steeper as it goes up, but it is working its way up. And one of the reasons that this was so interesting is when you look in more detail with one of these images, you can actually see evidence of water flowing from up on the hill down into the ravine, if you will. And so they knew that water was flowing there a long time ago. And so they thought this would be a good place to look for evidence that at one time Mars was a habitable place. And they've pretty much established that fact. And so they're just continuing to study the geology and understand more and more about the chemistry of Mars. So
Gerald,
anyway, just share it. Yep.
During the video, there was the panorama view of the dark material that they said they had to divert around. Are we looking at that same dark material from the aerial photograph?
Right in here.
That's what I thought. Yeah. Okay.
Yeah. So they're having to, there's quite a few obstacles that they have to navigate around. One of the things that he talked about during the video or during the lecture today was the fact that the rocks, there's rock beds there where the rocks are very hard and very sharp edged because there's not as much erosion of the rocks, and that was punching holes in the metal wheels of the rover. And so they've now had to sort of navigate. They've now figured out a way to detect places where there's a lot of these sharp rocks, and they're having to navigate around them as they work their way up the side of Mount Sharp, because it was really becoming concerned that there was a lot of holes being punched in the wheels of the rover.
I was going to ask one other question about that. Oh, well, I forgot it. It slipped my mind. All right. Well, Renato asked a question about the gravitational lensing. He has an excellent question. He says he still didn't get why the gravitational lensing was creating a quadruple image. And the best way I could explain that is, well, imagine a lens that you buy from an optical shop, and that's going to be a perfect lens. It means that the light that hits it anywhere on the glass is going to come to a focus in a single point, and you expect that from a camera, you expect that from a lens. These gravitational lenses caused by massive distant galaxies, nobody is orienting those galaxies or molding the galaxies
or polishing them or
polishing the galaxies to have a perfect gravitational topology to act like a perfect lens. So what we had here were 2 galaxies, each one a quote-unquote lens in its own right, with their gravitational fields overlapping, and also each of those galaxies having high gravity areas as well as low gravity areas due to the concentration of mass in different parts of the galaxy, to basically different zones. And the result is kind of random, right? It could have been 3, it could have been 5. It ended up being 4 just because of the orientation of things and the topology of the gravitation from those two very massive objects.
Imagine a cracked mirror.
Yeah, there you go. Cracked mirror. Yep.
You'll see 2 images of yourself slightly offset from each other, and that's kind of what you got going on here.
Yeah, great example. Yep.
Hey, Jamie asks, since Nellie is shut down for tonight, do we have any pictures from Damien Peach of Saturn? Do we have any of those?
We showed one, I think, a week or 2 ago. I don't have any tonight.
Yeah. Okay.
Oh well.
We'll look for that for next time, maybe.
Yeah, I will. I'll take a look for one. Yeah, they're always fun to look at.
I've got a great animation he did of Mars, where he photographed Mars over several nights and caught the full rotation of Mars and made that into a little video. It's you look at it.
Very cool.
And he does this with an 11-inch telescope, just like Richard has, like John has, and I have. We all 3 of us have 11-inch telescopes, and we all just sit there and look at the stuff.
Never got any pictures like that.
No.
How in the heck did he do that?
Yeah, I take a look at Damien's photos, and I want to turn the 11-inch telescope into a coffee table.
Must be a really strange-looking coffee table.
Yeah, well, you never know. All right.
One last question we got here. Do you guys ever have rubber band fights in that room? Well, no. But
what a great idea.
But it's a good idea for the next, the next fog out we have. Maybe we'll do that.
Yeah.
Yeah. We'll take bets.
Yeah. If one of us is wearing an eye patch next week, you'll know what happened.
So one last question here is Sharon had asked, what are you guys seeing tonight? And nothing but the inside of the observatory.
And each other, which is why we're ready to get out of here.
And a lot of fog.
Is that the same Sharon Fletcher who used to work up here at Chabot?
Oh, I'll bet it is. I'll bet it is. She came by a couple weeks ago here.
Did she?
Yeah. Well, hi, Sharon.
All right.
Yep. Okay, so I guess same time next week.
And hopefully better weather.
Hopefully this gloomy weather will have passed by then, because
and we don't get any more smoke.
This is like San Diego June gloom in Oakland in August. So it's all very confusing to me, and hopefully it'll all go away in a week.
Yeah.
So we'll see what happens.
And if you happen to come up here next Friday for our Sunset Science program, pay us a visit.
Yeah.
We'll be around.
We'll be here.
All right.
Yeah.
Well, good night, everyone.
Good night, everybody.
Good night.
And thank you for